This is for Year 12 maths. It comes out of 14C in the binomial distribution, and it's what I call finding n. So it's a binomial distribution, but you don't know the value of n. So I'm interested in these two questions. What is the smallest number of shots the shooter can make to ensure the probability of more than 0.95 of hitting the bullseye at least once? So the probability that x is at least once is more than 0.95, where x is binomial, n is the number of shots, and the probability of success is 0.2. So the problem is I don't know what n is. So how do we do this by hand? So the probability that x is bigger than or equal to 1 is equal to 1 minus the probability that x is equal to 0. And the probability that x is equal to 0 is n0 0.20.8 n. And n0 is 1, that's 1. So that's 0.8 to the power of n. The probability that x is bigger than or equal to 1 is bigger than 0.95. And since this is the probability of x being bigger than or equal to 1, then I've got 1 minus the probability that x equals 0 is bigger than 0.95. And this is what the probability that x equals 0 is. So I've got 1 minus 0.8 to the power of n is bigger than 0.95. Therefore, 0.8 to the n is less than 0.05. And if I do that, I've got 0.8 to the power of x is less than 0.05. Solve for x. X is bigger than 13.42, therefore n equals 14. Now, in this particular case, I needed a calculator to solve this, but if it was a tech-free question, the numbers would be a little bit easier to solve. Okay, so what do I do in relation to technology? I'm looking for the probability that x is bigger than or equal to 1 is bigger than 0.95, and I know that means probability that x equals 0 is less than 0.05. Okay, so what can I do on my calculator? If I do interactive distribution discrete binomial PDF, when x equals 0, the number of trials is x, I don't know what that is, probability of success is 0.2, okay, that gives me a wrong argument type. I could do some trial and error. I could say, okay, let's look at 10. That's too big. Look at 11. That's too big still. Look at 13. Oh, that's just a little bit too big. Look at 14. Bingo, below 0.05, therefore n equals 14. You need 14 trials. Option number 2 is I'm going to select that. I'm going to jump out of here and I'm going to go edit paste. So there is my distribution. I'm now going to select it. I'm going to go up to the table, and then I'm going to go down the table until I get this value to be less than 0.05. 13 is 0.055. 14 is the first time it's below. Therefore, n equals 14.